So now we're on page 242. An example 11 at the top says to find the limit of the following using the dividing out technique. Even though it says diving, it should say dividing. And so what's that telling us is that if you plug in 1 directly, because it's the limit as x approaches 1, you're going to get 0 over 0, or the indeterminate form, so you need to divide it out. So the first thing you need to do is you need to factor the denominator, which I did right here. And then I need you to pause the video and I need you to practice with your friend and see if you can apply this dividing out technique. And once you've done that, you can come back to the video and check yourself. So I used the dividing out technique, and the top is x minus 1, and the bottom factors out into x squared plus 1, x minus 1. So my x minus 1's cancel out, and so now I'm just left with a limit as x approaches 1 of 1 over x squared plus 1. And so now that I've divided out the issue, I can plug in 1 directly, and so when you do, you get 1 over 1 squared plus 1, which is 1/2. And so the limit as x approaches 1 of this function is 1/2. Example 12 says that I'm going to use what's called the rationalization technique. And so what that means is that I'm going to have to rationalize my numerator. And so hopefully you remember that things that have a square root or i's have things called a conjugate or a complex conjugate. So what I'm going to do is a lot of algebra. So I'm going to have the square root of x plus 1 minus 1 all over x times the conjugate, which is going to be the square root of x plus 1 over the square root of x plus 1 plus 1. And because you're multiplying by the same thing over the same thing, it's like multiplying by 1, so you're not changing anything. And so then you have to FOIL. And so when you FOIL this out, you're going to get the square root and the square root, which is going to be squared, is just going to get you x plus 1, and then you're going to have plus the square root of x plus 1 minus the square root of x plus 1, and then a negative 1 times a 1 is going to be a minus 1, all over x times the square root of x plus 1 plus x. And so when you look at this, the beauty of the conjugate is that things should cancel out, which it does. This and this cancel out. So now really on top, and also even more beautiful, is that this one and that one cancel out. And then I'm going to actually undistribute this x that I put in the bottom. So right now I have the limit as x approaches 0, and in case you missed my little note right here, I need you to change this as x approaches 0, not 1. And so now on top I just have an x, and on bottom I have the x that I pulled out, and then I have my x plus 1 plus 1. Well, the reason obviously you can see now that I pulled this x back out is that these x's are going to cancel. And now that those x's cancel, I'm left with the limit as x approaches 0 of 1 over the square root of x plus 1 plus 1. And so when I plug my 0 in, I get 1 over the square root of 1 plus 1, which is like saying 1 over 2, because the square root of 1 is 1. And so the limit of this rational problem is that its limit as x approaches 0 is 1/2. And so some other important notes. So we can use technology and we can make a table or look at the graph, but we have these things called one-sided limits. And so that's kind of what we did earlier, where we do the table where we do one side and then the other side. So when you go at the graph from the left or from the smaller side of the number, you're going at it from the left. And if you go at the number from the positive side or from the bigger side of the number, you're coming at it from the right. And so it says that limits generally only exist when functions approach the same value from the left and right. When you approach the same value from only the left or from the right, it's called a one-sided limit. And so then this problem down here says, find the limit as x approaches 0 from the left and the limit from x approaches 0 from the right. So if I were to write this, I would do the limit as x approaches 0, and then a negative, which means from the left, of the absolute value of 2x over x. So what that means is that you're going to let x equal things like negative 0.01, or negative 0.001, or negative 0.0001. And so what I've done is I've already graphed this on my calculator. And so this side down here is the left side. And so when I plug in really small x values right in here, you can see that my limit is going towards negative 2. So the limit of this is going to be negative 2. But if I do the limit as x approaches 0 from the right of the absolute value of 2x over x, that means you're plugging in things like things just about to 0, so on the other side. So like 0.1 or 0.01, 0.001. And when you do that, you look at the graph, you can see that that's this side right here, you're going towards 2. So this thing's left-handed or left-sided limit is -2, and the right-sided limit is 2. Okay, so then you need to make sure that you know that the limit of a function only exists if the left and the right agree, which means the overall function only has a limit if the left and the right agree. So now what you need to do is you need to stop the video, you need to try this problem, and you should give a shot at this problem too, and then go back to Edmodo and watch the next video that has the 2 answers on it.